Hey John, how you doing? I've optimized this thing um, to a 5 pound pumpkin, and I've set it up so that I have two variables over here. One is the pumpkin weight, which I have set at 5, and the other is the mass counterweight, which I had to reduce from 120 down to 80 in order to make this thing fit properly. If you'll let me go through the run, and you'll see that the pumpkin um, is going up, and this, after just taking a protractor and putting it on the screen, turns out to be 60 degrees. Also, notice the fact that the throwing arm is completely stalled, which means that all the energy that we're producing is getting put into that pumpkin. Now, if I take a look at this on the distance chart, let me do that. You can see that I've taken the speed and I put it into this variable. On the mass, I have it down to 5 pounds, and the direction, that 60 degrees that we calculated before, translates to 1.05 radians. So if I run this, whoops, let me do a reset and clear and do a run. Okay, that's about 156 feet. So that's what I'm optimized to. Now the only change I'm going to make here is, let me reset it and clear it. I'm going to change the weight of the pumpkin down to 4 pounds. Okay, and let's go ahead and rerun, all the rest being equal. And if I let that thing go, notice the fact that the angle is quite a bit less, and the pumpkin is going quite a bit faster. We're up to 47 miles an hour, so 48 miles an hour. Let me calculate that. Okay, the actual, if I go back here, the angle of this thing going out is around 50 degrees or so. If I look, and that translates to 0.87 radians. And I put the speed in there. 47 really should be about 48. The mass of the pumpkin, that goes back down to 4. Oh, it won't let me do that. Let me change that. Okay, that's changed. And let me go ahead and do that run. And if you'll notice, it's considerably flatter than we saw before, and it goes out 240 feet. So there's a sizable difference between a 5 and a 4 pound pumpkin. Now let's do the same thing with the 9 pound pumpkin. This is when things start getting pretty dramatic. I'll change that to 9, and let's go ahead and run it. Notice the fact that I stalled very early. Oh, by the way, the release of the pumpkin is being based on the angle between the sling and the actual throwing arm. And that's why it's remaining constant. And if you'll notice, we actually pulled that thing backwards with that pumpkin, and it's going pretty high. As a matter of fact, dangerously close. If I take these numbers and I put them in, I'll put those numbers in. Let's see, the speed of the pumpkin is down to 30 miles an hour. Our mass is now 9 pounds. And the direction of the pumpkin was actually about 65 or no, 75 degrees. So that's 1.31 radians. Let's go ahead and run that. And notice that thing is taken up pretty high. Okay, and I have a distance of probably about 53 feet. This is getting pretty dangerous. because it's so close. We'll follow up with this later.